Hi guys, this is the probability of at least one success. So the strategy here, so the idea is we have a set of things happening, and we want the probability that something will happen at least once. So in all the other stuff we've been doing, we've been talking about the probability that something will happen a specific number of times. But this is what happens if something happens at least once. So what's the probability? Essentially, we're saying what's the probability that it won't not happen? Sorry for the double negative. But so if that makes sense, like if for example, in one of the videos we had, what's if someone answers randomly on a test, what was the probability they got? 5, right? So this would be an example of this would be what's the probability that they didn't get them all wrong, right? Is what we're saying. What's the probability they didn't get them all wrong? So the strategy here is to figure out what the probability is that they were all wrong, or they were all the other thing from what we want. And then if we know that probability, then we can just say, well, the probability that that doesn't happen is going to be 100% minus whatever we found. So if there's a 2% probability that the person got every question on the test wrong, then there's a 98% possibility that they got at least one right. Does that make sense? So let's do an example. So when a customer places an order at Darren's Bakery, there is an 85% probability that the order will include some kind of dessert. One day, 7 customers place orders at Darren's Bakery. Assuming that each order is equally likely to include dessert, what is the probability that at least one order will not include dessert? So we want to know the probability of at least one without dessert. So using our strategy, we need to figure out what the probability is that they will all include dessert. So what's the probability of the opposite thing happening for everybody? So we want the probability that they all include dessert. The probability that one order includes dessert is 85%. So we want the probability that all 7 include dessert. And these are independent, so we just need to multiply 85% by itself 7 times. Remember, we want to use the decimal form, so 0.85. So we're doing 0.85 times 0.85, etc., 7 times. So we can write that as 0.85 to the 7th, right? So we don't have to write it out 7 times. So if you put that in a calculator, you get 0.321-ish. So I would use the exact thing that's in your calculator, but this would be approximately 0.321. So what we're going to do is we're going to say, okay, well, it's a 32% chance that nobody orders dessert. So if the other was that 68% chance must be there must be a 68% chance that somebody will order dessert. If there's a 32% chance that nobody will, because 32 plus 68 is 100. So the way we do that mathematically with decimals is just 1 minus 0.321. And I would use the number that's sitting in your calculator because that's more exact. Whoopsies. I hit the wrong button. There we go. So that would be 0.6794, etc. But it asks for the nearest hundredth. So that's 0.68, or like I said, 68%. In this case, doing it in our head would have gotten us as close as we need. But sometimes it asks for 3 decimal places. Sometimes it asks for other things. So it's good just to keep the exact number in your calculator so that you don't have rounding errors, especially with Khan Academy, because they don't like those. So that's the strategy here. We're finding out the probability that the opposite happens, and then it's 1 minus that probability, essentially. So let me know if you have any questions, and I'll see you guys later.